carbon and its compounds, and I think I've finished with functional group. I hope you have gone through the video. Now let us see the chemical properties of carbon compound or carbon hydrocarbons, right? So under this we'll be learning about combustion, oxidation and addition and substitution reaction. So let us start with combustion reaction. So what is combustion? Combustion is nothing but heating a substance very strongly in excess of oxygen or in air. Okay, you are heating a substance in excess of oxygen or in air. Why air? Air contains some, it contains oxygen. So when it burns, what happens? It gets oxidized. They get oxidized. See, carbon in all its allotrophic form, whether it is you are taking coal, charcoal, even diamond also, when you heat to a very high temperature, even it will burn. Okay, right? So carbon in all its allotrophic form, it will react with oxygen, forming carbon dioxide. And this combustion reaction is a highly exothermic reaction. It will release a lot of heat as well as light. Okay, so this is carbon. Now let us see the organic compound, that is carbon compounds. What happens when they burn, right? When they are heated strongly in excess of oxygen or in air. So whatever it is, all the carbon, that is all the organic compound. Okay, organic compound means what? Which contains carbon and hydrogen in it. You take any organic compound, it will react with oxygen and they will undergo oxidation reaction. That is, carbon also will get oxidized and hydrogen will also get oxidized and releasing a lot of energy. Heat is released and light is also formed, right? Light is also released. Okay, so the first organic compound, that is methane. CH4 is methane. So when it is heated with oxygen, it releases carbon dioxide and water. Any combustion reaction, it will release carbon dioxide and water with a lot of energy, heat and light. Okay, so this is methane. And what is C2H4? C2H4, you know very well, it is ethene, right? You remember C2H4, right? C2H4. Carbon-carbon double bond. So this is ethene. So when ethene is combusted, right? When it is burnt, right? So it will release carbon dioxide and water with lot of heat and light. And what is C2H5OH, right? So C2H5OH is nothing but ethyl alcohol. When it is made to react with oxygen, again carbon and hydrogen get oxidized and forms carbon dioxide and water with lot of heat and light. Now, when we see, like sometimes we use LPG gas, right, as cooking fuel. Sometimes it gives a very good bluish flame. Okay, sometimes it gives a yellow color flame. What is the reason? Some, like when when you burn the wood, usually burning wood will give us the yellowish flame. But LPG usually should give blue flame. Why? Because the LPG contains what? It is a mixture of propane and butane. Propane and butane. So when I say propane and butane, what organic compound it is? It is a saturated hydrocarbon, isn't it? So saturated hydrocarbon, whenever it is burned, it gives a very clean flame. Saturated hydrocarbon always gives blue flame or clean flame. Okay? Sometimes what happens, LPG, when the stove, the burner in the stove will get blocked. Maybe when something is spilled, so it gets deposited, and that tiny holes will get blocked by these dirt. So what will happen? It will not get enough of oxygen, so the gas will not burn. So it will be containing unburned carbon. So you should remember, saturated hydrocarbon always gives us blue flame, and unsaturated hydrocarbon. unsaturated hydrocarbon. So which are the unsaturated hydrocarbon? You take propene, propan, butane, butane. They give hydrocarbons will give yellow. That is what? Orangish color, right? Yellow color flame. Okay, this you remember. Saturated hydrocarbon gives blue flame, and unsaturated hydrocarbon will give yellow flame. And I was also telling the LPG gas contain like propane and butane. It's a mixture of propane and butane, which are nothing but saturated hydrocarbon. So it will give blue flame. But sometime what happens when the burners, like if dirt is collected in the burner, it will not get sufficient oxygen. Oxygen is necessary for burning, right? So because of which the carbon particle will not be completely burned. That's why it becomes yellowish color, and that soot will get collected. And we should also remember, whenever we are burning coal, right? Coal and petroleum. What happens? It also releases oxides of nitrogen and sulfur. You know very well they are air pollutants, and we have to make sure that in no way we pollute the environment. And at the same time, I was telling about the LPG gas stove, the burner. We have to clean the burner periodically so that we save the fuel, we save the energy. But here the main point you have to learn is combustion of carbon compound will give carbon dioxide and oxygen, and carbon dioxide and water, releasing lot of heat and energy because it is highly exothermic reaction. In this reaction, both carbon and hydrogen will get oxidized. And one more point we have to remember is unsaturated hydrocarbon always gives us yellow flame, and saturated hydrocarbon will give clean blue color flame. Okay, understood? Okay, so now let us see the next chemical properties. That is, already we learned that during combustion they also undergo oxidation. The carbon compound will also undergo oxidation reaction. So in your textbook they are given one small activity. So based on that, let me explain. So oxidation, so carbon compounds can be easily oxidized on combustion. That's what we learned. When methane or ethene or ethine, okay, anything you take, butane, okay, when it is burned with oxygen, right? So it will undergo combustion. So when it undergoes combustion, it's nothing but they undergo oxidation reaction. Both carbon and hydrogen will get oxidized. Okay, that's what we learned. So carbon compounds can be easily oxidized on combustion. Sometimes the alcohol, that is here, this is also organic compound. The alcohol, which alcohol is this one? CH3, CH2OH is ethyl alcohol. It is called ethanol. So you take ethanol, propanol, okay, or methanol. So these alcohols are converted into carboxylic acid. Ethanol can be converted into carboxylic acid. You know the carboxylic acid functional group, that is COOH, right? It can be converted, alcohols can be converted into carboxylic acid by using suitable oxidizing agent. So this example is given. So CH3, CH2OH. It is nothing but ethyl alcohol. We know that. It is commonly called ethyl alcohol, or chemically you can call this ethanol. Okay, when ethanol is heated with alkaline potassium permanganate and you heat it, or acidified potassium chromate, right, and you heat it, the alcohol will get converted into carboxylic acid. So it is CH3COOH. So it will get converted to ethanoic acid. So alcohols will get converted to carboxylic acid by using oxidizing agent. Here it is, we have used alkaline potassium permanganate KMnO4, or acidified potassium chromate, and you heat it, the alcohol will get converted to ethanoic acid. They add the oxygen, that's why it is called oxidizing agent. So that's about oxidation. So let us learn about the next reaction, that is addition reaction. So it's a reaction wherein you're converting unsaturated hydrocarbon into saturated hydrocarbon. So we know what is unsaturated hydrocarbon. That is carbon-carbon double bond or carbon-carbon triple bond. Carbon-carbon double bond or carbon-carbon triple bond. So this is unsaturated hydrocarbon. The unsaturated hydrocarbon will be converted into carbon-carbon single bond. That is unsaturated to saturated hydrocarbon. Converting unsaturated hydrocarbon into saturated hydrocarbon in the presence of suitable catalyst. Maybe they can use nickel or they can use palladium for catalyst. You know very well, catalyst will help in accelerating the reaction, rate of reaction without affecting the overall chemical reaction. Catalysts are the substances which will increase the rate of reaction. They themselves will not undergo any type of changes, and in no way they affect or alter the chemical reaction. Only that they will speed up the reaction. That is the function of catalyst. Okay. So when you take unsaturated hydrocarbon and you pass hydrogen gas and in the presence of the catalyst, the unsaturated hydrocarbon will be converted into saturated hydrocarbon. For example, let us take this one. What is this? This is ethane. So this is ethane because carbon-carbon triple bond. Okay, so you take carbon, ethane, and pass hydrogen gas in the presence of nickel, and here you can see that ethane has changed to ethane. Ethane has changed to ethane because when you pass hydrogen gas, so it is contributing the hydrogen. See here, how many hydrogen? See, carbon, triple bond, carbon, and 2H, right? And here you see 2, it has around 4H. It has contributed 4H, right? So 4H and its own 2H. So it totally became C2H6. So it has converted from ethane. Ethane is unsaturated, which is unsaturated. It has converted to saturated hydrocarbon. This is called addition reaction. They are adding the hydrogen, and that is why it is called addition reaction. Remember, this is very, very important. This is also important. The previous one reaction where I told you oxidation in the presence of alkaline potassium permanganate, that reaction is also very much important. This is also important. So let us do one more with the help of ethene. Okay. So ethene we know very well. It is carbon-carbon double bond. Carbon-carbon double bond. This is ethene, which is unsaturated. Okay. Wherever you see double bond and triple bond, you know very well it is unsaturated. So this is unsaturated hydrocarbon, and you are passing hydrogen gas in the presence of either nickel or palladium, and you are going to convert that into saturated hydrocarbon. See, C4. Okay, so C4 and only 2H, right? So this is what we call addition reaction. This entire process where you are converting unsaturated hydrocarbon to saturated hydrocarbon, this is ethane, saturated hydrocarbon, by passing hydrogen gas over it is called hydrogenation process. This process is called hydrogenation process. This process is called hydrogenation process. Okay. So this process actually used for converting the oil to solid state, right? So like you take any of the oil and they convert that into like the vanaspati dalda. You know that vanaspati dalda is actually converting oil to the solid state. That is, unsaturated hydrocarbon has been converted into saturated hydrocarbon. Okay, so that's called hydrogenation process, and hydrogenation of oil also you should remember. Let me give you the definition for hydrogenation. Addition of hydrogen to unsaturated hydrocarbon in the presence of a catalyst is known as catalytic hydrogenation. So hydrogenation of oil, you are converting the edible oil into fat. Okay, that is dalda, I told you, right? So you have seen that is you would have seen that ad and vanaspati dalda something. Dalda, it is converting maybe groundnut oil or coconut oil. It is converted into solid form, from liquid to solid state, right? The liquid form of oil is unsaturated oil. That will be converted to saturated. So example is dalda. Any edible oil. Edible means which we use it for cooking, right? So that is unsaturated. In the presence of, when you pass hydrogen over it, in the presence of nickel and you heat it, it will be converted into saturated or the fat. Okay, so this is the general formula for it. Learn the general formula. So this is also important for your examination point of view. So next, let us see substitution reaction. So here, the saturated hydrocarbon, usually it is unreactive with most of the reagent. They are unreactive and they are inert actually in presence of most reagent. But in the presence of sunlight, that is in the presence of UV light, if the chlorine will react and it will be added to hydrocarbon in a very fast reaction, and the chlorine can replace the hydrogen atom one by one. So let us take this one example. This is methane, you know very well. So this is methane. So it is made to react with chlorine. So chlorine, you know, it is diatomic in nature, and in the presence of UV light, or write it as sunlight only. In the presence of sunlight, actually it is UV radiation. So what happens? This chlorine atom will replace one of the hydrogen. So let us see what will happen. So it will replace one of the hydrogen. Okay, so out of two chlorine atoms, one will be replacing one of the hydrogen, and it will take, the chlorine will take the place of the hydrogen, and it forms HCl. Okay, and it continues. One by one it will be continuing. Now from methane it has become chloromethane. So it has become chloromethane. Now this chloromethane again will undergo reaction. So let us take chloromethane. Let me write down this one. That will be easy for you to learn faster. Substitution reaction. So what happened here is CH4 plus Cl2. You got CH3Cl plus HCl. You understood from where you got HCl. This H, right? This H which is substituted by Cl chlorine. This H and one Cl has combined to form HCl. So this continues. It won't stop like that only. Now let us take CH3Cl. Okay, now CH3Cl will take. So CH3Cl. CH3Cl plus Cl2 in the presence of sunlight. Okay, now what will happen? So it will, one more H will be replaced by chlorine. So plus HCl. Okay. So now what happens? CH3Cl plus Cl2. You got CH2Cl2 HCl. Okay, this is what you got it. Then again it will not stop with this. So let us continue, right? Next what happened? This one will take, that is CH2Cl2, right? CH2Cl2 with chlorine, with sunlight, and now what will happen? 3 hydrogen atoms have been replaced. Okay, 3 hydrogen atom has been replaced. Now what you got? CH2Cl2 gave you CHCl3 plus HCl. Okay. Now again it will continue. Okay. Next what happened? CH is there. CHCl3 plus Cl2 in the presence of sunlight. Now what happened? All the H has been replaced and we got CCl4, carbon tetrachloride. Carbon tetrachloride. Okay, so this is substitution reaction. Okay, so this also you learn. This is also important, right? So I think we finished with the chemical properties of carbon compound. I hope you understood.